Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes ways. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome back to this dynamic programming series. I am very pleased to see you all here, and this is our day 4 of the series. So before we start, can I please get a quick confirmation if my voice is clearly audible and also if my screen is clearly visible? Yeah. Okay. Okay, thanks for the confirmation, guys. Let's just wait for a couple more minutes so that rest of our friends shall also join, and then we will be starting it, all right? And this is our day 4. Let me write it down. And the topic that we are going to discuss today is LCS. That is longest common subsequence and longest common substring. Okay. So yeah. This is going to be our topic for today. All right, I guess we are good to go. So, okay, so welcome to this day 4. And before we begin this, let me quickly have a recapitulation of what we did in the previous sessions. In the first session, it was intro to DP, all right, why we need DP and what is the need for DP, how we can identify if it is a DP question or not. And in the second and third session, we had knapsack problems, all right. We first of all looked at what knapsack is, okay, what are the input statement and what is the demand of the output, all those things were discussed. And in the third session, we discussed about the problems that are based on the knapsack, okay, because all of the problems are related. So, you need to find out the similarities between the problems so that, you can figure out which problem is based on what concept, and then, you can use those concepts to solve the questions. Okay. All right. Voice is breaking. I mean, is this problem with everyone? Is everyone facing the same issue? Or like, is it clear now, or is it again breaking? All right. Okay, so just give me a moment. Okay, I will rejoin maybe. Okay, clear? All right. So, okay, once if it is not clear, do let me know. All right, I will just rejoin. Okay. And yeah, thanks for letting me know. So, let us begin our today's concept, that is LCS. Okay, which is longest common subsequence. All right. So before we start, I want you all to help me with what is the difference, like this is an easy question. What is the difference between a subsequence and substring? Okay, let us see who answers this. Obviously everyone would, but then I want you all to answer this question. What is the difference between a subsequence and a substring? Is my voice breaking? I am audible, right? Not audible? All right, so I guess there is some confusion around what is a subsequence and what is a substring. So let me, okay, thanks. So all right, Naikaj, the answer given by you, that is correct. And Vishwanath, the answer that you gave is a small part of sequence is called subsequence. Okay, it is partially correct. All right, so let us now see what the subsequence and a substring is. And thanks, Tanishq, for the confirmation. So see what happens in a substring is, let us say a string is given to you, geeks for geeks. Okay, so substring need not to be a continuous portion of that string. Okay, so like see, let us say one of the substring can be KOREKS. Okay, this can be one of the substring, like I have taken KOREKS. Okay, I have taken these characters and then I have formed this string. Okay, so this is a substring. One thing is, you must always move forward, right? Once you have started from K, you can't add G, like you can't add this G. Okay, you can add this G, but you can't add this G. So this is a subsequence. It need not to be continuous, and it is like the every string that you can form out of the given string. All right, whether continuous or non-continuous. Now what is substring? Substring needs to be a continuous segment. Okay, let us say if geeks for geeks is there, so the substring needs to be a continuous section of that string. Okay, it has to be continuous, right? Like these things. Okay, these two, these are the substring, right? So are we clear about the difference between substring and subsequence? Subsequence are a set of all the strings that can be formed from the given string. It need not be continuous, but substring has to be continuous. Okay, this is the major difference. Are we clear? All of you can let me know in the chat section if you are clear on this. Okay, thanks, Bharat. And how many of you are joining this session, joining the series for the first day? And how many of you are following it from the day one? Like this is our day 4, right? So I want to know that how many of you are like, this is the first session of yours. Okay, so hi Vishwanath. Make sure you are accessing the videos of day 1, 2, and 3 as well. It will help you in clearing your concepts. Okay, so welcome Rahul to our first day. Let us know if there is anything that is that is you want me to explain, or if there is any clarification that you need. Please feel free to write it down in the chat section. Okay, I'll be very happy to clear it out. Now, so we are clear on subsequence and substring. Now let us move ahead. What we are going to do is, hi Priyanshi. So what we are going to do is, today we are going to cover longest common subsequence. Okay. So what happens in a longest common subsequence? Okay. First of all, let us discuss the input statement. Okay, so again, hi everyone. I hope the voice is clear now. Please let me know. Yeah. Is it clear now or better than before? Great. Thanks, Rahul. Okay, so longest common subsequence. So how does the input statement looks like is, you will be having two strings, say S1 and S2, right? So now what is this S1? That is going to be, let us say it is A, B, C, D, G, H, and the second string is A, E, D, F, HR. Okay, you need to find out the length of the longest common subsequence. Okay, so if you will carefully look into these strings, this A is common, then we have D common, and then we have H common, right? So the longest common subsequence here that we have is ADH, and the length of that substring is 3. Okay, so the input statement, you will be given two strings, and the output you need to return the length of the longest common substring. Cool. So that is how our problem statement will look like. Now, let us start thinking how we need to solve this. Now, first of all, before moving ahead, let me tell you why this is a DP question. First, because we have to make an optimal choice. Why optimal? Here we are figuring out, if there is a max, min, or something like that. Here we are trying to find out the max. Okay. So this is the first problem. And second, here we have to make a choice, right? Choice making is there. Okay. How choice making means, we are deciding that whether we need to consider this character or not, whether we need to consider this character or not for our answer, right? So and also there is a substructure, like you can divide this big problem into smaller sub problems. Okay, sub problems property is there. How you can divide is, like, this entire string is given to you. First of all, you can check that what is the LCS of this complete string. Okay, then you can delete this character, and then you can try to find out the LCS between this string till G and this entire string, right? So we can you can try out multiple substructure, like you can break this problem into smaller sub problems, and then you can solve it, right? So on the basis of these two conditions, what we can say is, this is going to be a DP problem. Now, as it is a DP problem, what is the first approach that we use for solving a DP question? We can directly, you can form the matrix and start solving it, but then it can cause some issues, or it cannot help you to build an intuition. So what is the first thing? Yeah, Nikas, that's correct. We are going to use recursion. Yes, Miral, you are correct as well. So, okay, let us discuss our first approach, that is recursion. All right. What is the one most important thing about recursion whenever you write a recursive code? Base case. That's great, Bharat. Yes, Miral, Naikaj as well. All of you are correct. The first thing is base case. Now, how do we find base case in our recursive code? What we do is whatever inputs are given to us, okay, we try to break that input into smaller and smaller strings. Let us say the input is A, B, C, D, G, H, and the other input is A, E, D, F, H, R. Okay, these two strings are given to you. So, like for base case, what we do is we try to break down the input into smaller and smaller parts, and then we see that what could be the least smallest value of an input. All right, and then whatever is that least value, that is going to be our base case. Okay, so in this case, the length of the string here is 1, 2, 3, 4, 5, 6, and here it is again 6. Okay, so tell me if S1 and S2 are given to you, what could be the least value of S1 or S2? Let us say this is N, this is M. Okay, sorry to bother, but voice is breaking again. Let me try something else. Better now? Hi everyone, I will just read out the thing that is written on the screen. So we are discussing the recursive approach, and in the recursive approach we have two strings given to us, S1 and S2, and we are trying to find out what could be the smallest possible value of S1 or S2. Still not clear, right? I don't know why this problem is happening. I mean, it used to be the okay, clear. I didn't do anything, and then alright guys, so tell me, if we have two strings given to us, that is S1 and S2, what could be the smallest possible value of S1 or S2? Like we have two integer values N and M. What is the smallest value that they can take? That is going to be our base case. Okay. So what is that smallest possible value? Zero. Okay. 1. All right. Okay. So let me tell you this thing. Can we have an empty string? Like let us say if S1 is this. Okay. Empty. Can we have that empty string? Is that not possible? That S1 is given to you as an empty string and S2 is given to you as ABC. Is this not possible? Why not possible? Because it can happen that the string is an empty string, right? Okay, so whenever you are required, like let us say a string is given to you ABCD, and whenever you are required to create all the subsets of the string, so isn't the empty substring is also one of the subsets? So it means that empty substring is there. So that can be also one of the possible inputs that we have. Alright. So on that basis, what we can say is the least value that N and M can assume is 0. Alright. And this is going to form our base case. Cool. Is this thing clear to you all? The smallest possible value? Yes, exactly. Base case is 0. Let's correct package. So the smallest input that we can have is the size of the string. Okay, that is n or m that can be is equal to 0. This is the smallest input. Okay, now tell me if size of the string is 0. Let us say one of the strings that is okay. Wait. Let us say if one of the strings that is given to you is an empty, and the other string that is given to you is say dynamic. Okay. So now tell me if these are the two strings that is given to. Is there any subsequence that is common to both of them? Can you find out any similarity? Like not similarity, any character which is common in S1 and S2? If one of the string is empty and if other string is having say 4, 5, 6 or whatever number of characters, n number of characters, empty character common. Okay, how it is common? Like S2 is not having any empty character. Empty substring is a subset of it. All right, here in this case we don't have any empty character here, right? In S2, S2 contains of what? Like if you will draw it out, S2 is like this, and then a null vector at the end, which denotes the termination. So S2 is looking like this. So here it is not having any empty character that is there. Okay. So now tell me if S1, if one of the strings is empty and if other string is having any n number of characters, so what is going to be the longest common subsequence between them? No match. Exactly, Bharat, like that's pretty much correct. So, all of you have already figured it out. If n is 0, thank you so much, Shishir, or m is equal to 0, then we will simply return 0, right? It means that none of the characters are common. Is this, and this is going to be our base case. Okay, is this base case clear to you all? Great. Thanks, Pankaj. Thanks, Trisha, for the confirmation. I hope this series will help you in your preparation journey as well. And all of you can take some help from the questions that you are solving there to build the intuitions. Okay, so the base case is clear to us, right? So, all right, so if once base case is done, then, thank you so much, Shisha. It really means a lot. So, now let us write our function, okay? Let us say the function is int LCS, and we have strings given here as string S1, string S2, int n, int m, okay? Now, the base case that we have written is, let me use a different one. The base case is if n is equal to 0, or if m is 0, we will simply return 0, right? Okay, so n is the size of S1 and m is the size of S2, right? So this is our base case. Now, what we will check is, we will start checking from, let me use the previous page. See, what we are doing is the string that is given to you, okay? Let us say, what was that? A, B, C, D, G, H, okay? And the other string that was given to us was A, E, D, F, H, R. Okay, so it is A, E, D, F, H, R. Okay, so what we will do is we will start checking from the end. Okay, we will see if this n character is matching or not, right? Okay, let us say in this case it is not matching. Let me take the example where it is matching. Okay, so let us say this is our second string. Okay, so what we will do first of all, we will check that okay, we are starting from the bigger problem and then we are converting it into smaller sub problems, right? So let us say first of all we will check for the last character, that is H here and H here. So if it is matching, it means that it can be a part of longest common subsequence. Is this concept clear? So what we need to do is once this last character has matched, we will do our operation on this much of length. Okay, AEDF, ABC, DG. Okay, on this part, right? Okay, clear to you, Nikaj? Okay, that's great. Now let us see if other people are also getting this point. Like we will match the last character. If that comes out to be common, then it means that length has been increased by 1 as well. We have one character common, so we will increase the length by 1 and then we will do the process for this much of string. Okay, the left part of the string. All right, thanks Meryl for the confirmation. So now what we can write here is if S1 at n minus 1 is equal to S2 at m minus 1. Okay, yeah, exactly, Nikesh, that's pretty much correct. We will return 1 plus LCS of S1, S2, and we have decreased the length by 1 unit, right? Because the last character has already been evaluated. So is this 2 line of code clear to you all? Kindly let me know. Thanks, Bharat. Thanks, Meryl. Okay, thanks, Michael, as well. And all right, one thing more, I would like all of you, whoever are in this session right now, please do give it a like, and I would really appreciate it. So whatever is the number of audiences that we have here in the live chat, I request everyone to give a like for this session. All right. Okay. Right. So now this has happened. Now what can be the other case? Thank you so much, Nikes. Okay. So one case can be if the last character matches. Now what can be the other case if the last character is not matching, right? Let us say this string is A, B, C, D, G, H. Okay. And this string given to us is A, E, D, F, H, R. Okay. So now in this case, if you will see the last character, here it is H and here it is R. It is not matching, right? So in that case, if it is not matching, what you can do is either you can for the next evaluation, what you can do is rather than deleting both the characters at once, what you can do is first of all take this entire string and take this string till H only, right? And in the second option, what you can do is either take this one as an entire string, okay, and take this string till G only, right? Because it might happen that H and R are not matching, but then the second last character of this string, that is H, it is matching from this H, right? So rather than deleting both the characters, you should need to check. See, we are including when the last character is getting matched, okay? Now, and we are excluding it if the last character is not getting matched, right? So rather than excluding both the character at one time, in this case, what we were doing, we were excluding both the characters at once, right? N minus 1, M minus 1. Here, what we are going to do is here, first of all, keep it N minus 1, M, and in another case, keep it N and M minus 1, okay? And then check what is the max from these two conditions, okay? So whatever it is going to be our optimal answer. So that is what we are trying to do in the case when character is not matched. Let me know if this concept is clear, or otherwise I shall explain it again. Because see, like here it was A, B, C, D, GH. Okay, and here it is A E D F H R, right? Now the last character is not getting matched, H is not getting matched, but H is getting matched to the second last character, right? So if you will delete this H and this R both at once, then drawing is not visible. I guess, I mean, what is happening? Is it visible now? Okay, it's visible. Yeah, so what I was saying was, if you can see A, B, C, D, G, H and A, E, D, F, H, R, okay, in this case, H is not getting matched with R, that is clear, but H is getting matched with the second last character. So, if the last character is not getting matched, and just on the basis of that, if you will delete both of these characters, then you might lose one common character, right? So rather than deleting both the characters, what you need to do is first of all delete one character from one of the string and keep the second string as it is. Okay, and now delete one of the character from the second string and keep the first string as it is. Okay, so these are the two things that you can do when the last character is not getting matched. Okay, let me help you all with the diagram. So let us say what is happening, that last we have two strings, okay, S1, S2, and we have a last character that we are evaluating. Okay, if it is getting matched, simply reduce the length by 1. Okay, add last character to the result. If not getting matched, in that case, either do n m minus 1 or either do n minus 1 and m. Okay, you can do, and you need to find out what is the maximum, in which of the cases you are getting the maximum. Okay, these are the two conditions if the string's last character is not getting matched. Okay, so are these two conditions clear to you? This is basically the choices involved. Okay, choices that we are going to make. Okay, and that's why it is leading this question to be a DP problem, right? Yes, exactly. There are two calls if it is not getting matched. We will call for this thing, we'll call for this thing, and then we will find out the max length that we are getting from these two calls. Okay, thanks, Naikaj. So all of you can please give me a confirmation if these two choices are clear to you all. Thanks. Okay, so let us get back to our recursive code. Okay, so now in the case when the character is not matched, what we are going to write here is else. Okay, return max of LCS from S1, S2, keeping n as it is m minus 1, or LCS from S1, S2, n minus 1 and keeping the second string as it is. Okay, here I have not added 1 to the length because the strings are not. Okay, if you will revise it again, it will help you only to clear your concepts. And thanks for being with us in the session. All right, so okay, if we are not adding 1 here because the strings class characters haven't matched. Okay, so that's why it is not going to add it in the length. So that's why we will just simply reduce the length by 1 and then we will find out the max. Okay, whatever we are going to get from these two calls. Okay, so this is going to be our recursive code for this question. Please have a clear look at this recursive code and let me know if it is clear to you all. If not, I shall explain it again. and please feel free to ask. Okay, don't hesitate at all. I'm here to explain the things only. Okay, thanks, Miral, for the confirmation. All right, so the recursive code is clear to you all, right? But then, as we know, the recursive code is going to take a lot of time because of the recursive stack, and as well, lots of time and space. Okay, and as well, the thing is here that we are using two recursive calls. Okay, so the time complexity is going to be also quite exponentially high. That is, it is going to be 2 raised to the power n in that range. So that's why recursion code is not a good idea. But then we need to have a recursive code to have an intuition that what we need to write in the memoization or in the tabulation form. Okay, yeah, that's correct, Nikaj. Okay, so if the recursive code is clear to you all, let us now move to the second thing. That is, now we are going to have this memoization thing. Okay, what is the difference between recursion and memoization? The memoization code will be pretty much similar for the recursive code. The only difference that we are going to have is okay, we have discussed this in the previous sessions as well. Memoization will avoid overlapping. Okay. Okay, yeah, that's correct. Let us see if we have any more answers and how we are going to implement memoization. Yeah. So we are going to implement memoization using a 2D matrix. All right, that is correct. So like only I guess Miral is following the contents of the series. Okay, no issues. So everyone, if you're having any sort of doubt, please feel free to ask in the chat section, or you can access the previous videos as well. So what basically we do in memoization is we try to exactly like we store the pre-computed results. So we store the values that are already calculated. Okay, that are already calculated to avoid overlapping. Okay. Alright, so that is the reason why we use memoization. And now what we are going to do here is, let us say we will form a 2D matrix of size. Let us say for S1 we have the maximum value that the string can take is 1000, and for S2 as well the maximum value of the length is going to be 1000. Okay, so you can build a 2D matrix of size this. Okay, you can make it global so that you don't need to pass it again and again for the functions, right? So this is the 2D matrix that we are going to use. Okay, how we are going to decide the dimensions of the matrix? I have discussed it in the previous session as well, how we are going to decide the dimensions of the matrix. On what factors, like what are these dimensions, why we are taking it as n and m, like the size of the string. Yeah, okay, so like we have a correct answer. So what we are going to do is that is based on whatever the constraints that is given to you. Okay, so like the maximum value that S1 can take, that is 1000. Okay, so maximum value S can take is 1000. So make sure that you are the 2D array that you are creating, it is having a size like this. Okay, otherwise it will give you runtime error. So make sure the dimensions that you are selecting is of the maximum length that we have in the constraints. Okay, so once you have declared a 2D matrix, what you need to do is initialize it with a value say -1. Okay, don't initialize it with 0 because sometimes 0 can be an answer as well. So initialize it with -1. Okay. Okay. So what is that one function? I don't know if all of you are aware about it. There's one function that is used to initialize all the cells inside the matrix with a certain value, say -1. Like like this question or the previous question. First of all, let me clear out this question. This question was that what is the one function that is used? Yes, we can use the mean set. Okay. So what it does is it copies this character, whatever you will give it to. Okay. I don't remember the syntax exactly, but it is something like hi Shagun, and yes, your answer is correct. -1 t size of t. Okay. All of you can check out the syntax. I kind of don't remember it properly, but I guess this is the syntax that we have. So what it will do is whatever the 2D matrix that you have, it will initialize it with the value -1. Okay. Why we use 2D array? Because here we have two values n and m whose values are getting changed, right? Like if let us say S1 is having length of n and S2 is having length of m. So when you are evaluating, what we are doing is you are decreasing the size of n till 0, you are decreasing the size of m as well till 0. So this is the value that is changing. Okay, so there are two values that are being changed. So that's why a 2D array, okay, and use of an array to store the values. All right. I hope you are clear about this. Yeah. Okay, so are we clear about this mean set function and initialization of a 2D array for storing the pre-computed values? Like if this is clear, then you can easily convert that recursive code to the memoized code. You just need to add certain values. You just need to store the values. Okay. So all right, is this concept clear? Thanks, Shagul. Okay, so now let us see our recursive code where we have written it. Okay, so this is our recursive code. Now I'll just show you the modifications that we can do. So okay, this is the base case. If n is 0 or m is 0, we are simply going to return 0. It is going to remain same. Now what you can do here is if s1 at n -1, if it is equal to the last character, so okay, what you can do is when you are returning this 1 plus LCS, okay, before this one statement, that after this snippet, the one statement that you need to write is if t at n m is not equal to -1, then return t at n m. Okay, what it signifies is that if this length has already been evaluated, then you don't need to evaluate it again. Okay, if the value is not -1, it means that it has already been computed. Okay, so this is the first snippet, this is second, this will be third. Now before returning 1 plus LCS, what you need to do is just write here t at n m is equal to 1 plus LCS. Okay, so that is the only difference that we are going to have in memoized version. And here also, before returning, write this t at n m, okay, is equal to max of. Okay, so that is the difference how we can convert the recursive code into the memoized version. Why memoized? Because now before returning the values, what you are doing is you are storing it inside the 2D array. Okay, so the next time if the same problems come, okay, you don't need to evaluate it again, and you can check it here that whether it has already been evaluated or not, right? So this will reduce the time complexity, and yeah, this will reduce the time complexity. All right. So okay, is this memoized code clear to you all? Let me know in the chat section if this memoized code is clear, and then we shall move to the final top-down DP that we aim at for me. Okay. Actually, you can't say that it is linear because here as well again the recursive calls are being made, right? So this, yeah, we still don't have a linear time complexity. Alright, so I'm assuming that this memoized version is clear to you all, and now we are heading towards the top-down DP, okay? That is thought. So what we are going to discuss is top-down DP approach, okay? So very similar to what we have written in the recursive and memoized code, okay, not that much of difference. So first of all, what we will do is we will initialize a table of size n+1 and n+1, okay? And then what you will do is you will just start iterating, okay? And then, okay, if this is the table, let us say this is a matrix that we have created. So first of all, this initialization part, okay, this is n, this is m, okay? So in this initialization part, you need to fill it. Yeah, okay. So in this initialization part, how you need to fill it is, yeah, this is bottom up actually, I'm sorry. So in this initialization part, how you need to fill it, you need to fill it with the help of base case, okay? With base case, right? So the manner in which the table is being filled is, that is bottom up DP, and the memoized code that you saw was top down DP, okay? Thanks, Nikos, for correcting me. All right, so okay, so can anyone tell me what will be the first row filled out? This first row means that S1 length is 0. That is, it is an empty string, right? So in the case of the empty string, what was the value that we were returning? Initialization is done with the help of the base case of recursive code, okay? So in the case of recursive code, when the length was 0 or when it was an empty substring, what was the value that we were returning? Okay, 0. So alright, the value that we are going to return here is 0 and here 0 as well. Cool. So yeah, that is how the table will look like for the initialization, and for the rest of the matrix, how we are going to fill it is the choice diagram that we had in the recursive code. So like on the basis of that choice diagram, you will match the string, okay, the string's character. Okay, so if it is getting matched, then what you simply need to do is you simply need to add 1 to the length, okay? To the length means to the length that has previously already been calculated, okay? That is what we were doing in the recursive code. What you are doing, you are just adding 1 and then you are decreasing the value, like you are writing here n-1, m-1. Simply replace n and m by I and j and write here I-1 and j-1, right? And if it is not getting matched, then simply find out the max, okay, and store it in Tij, right? So that is how the table is going to get filled. Let me show you the code so it will become more clear. Alright guys, so this is the code that we have for the top-down DP. Sorry, for the bottom-up DP, what we are doing here is we are starting from the length 0 till x and like till the entire length of the string, and again the second loop we are running it from length 0 till the entire length of the second string, okay? So if the I is 0 or j is 0 means the first column and the first row of the matrix, right? So if that is 0, you can simply replace it with 0, okay? And if the character is getting matched, increase it by 1, increase the length by 1 in the cell value, and if it is not getting matched, then in that case find out the max of both the case, okay? That both cases were deleting one character and keeping the second string as it is, okay? And then in the last you can return the final cell value of your table, right? So this is the DP code that we have. And are you guys able to see the Okay, you guys are not able to see it. Yeah, I'm sorry, I just realized it. Yeah, are you guys able to see it now? What we are doing here is we are simply initializing our table, okay, and then we are like we are running the two loops for the two of the strings, and then if the first row or the first column comes out to be 0, we are filling it with 0. If the character is getting matched, simply add 1, okay, to the previously calculated values, and if the character is not getting matched, then find out the maximum by deleting one of the characters from string one at a time, right? Don't delete both the characters, delete one character and keep the second string as it is, find the maximum value, and then at the end you can return the final cell value, okay? Let me know if there is any issue with the code. And the time complexity, space complexity, both are now going to be what? I want you all to answer this. What will be the TC and SC in this case? N square. Yeah, that's correct, Middle. EC stands for? Yeah. So both n square, the time complexity and space complexity, both is going to be n square. Okay. So can I please get a quick thumbs up or a quick confirmation if this code is clear to you all? Yeah, that's actually more precise, Nix, if that is your name. Okay. So that is the more precise answer. The space complexity and time complexity is going to be x into y. Okay. Nikas, actually S1 and S2 are the string values. So maybe you are trying to write S1 dot size and S2 dot size. All right, so we are clear with this question. Okay, so now what we are going to do is there is a question that is very similar to this. And okay, are you guys able to see the tab of longest common substring? Or are we still in the previous tab of longest common subsequence? Thank you so much, Nix. It means a lot. Okay, so is the screen of longest common substring visible to you all? Or are we still on the previous tab? Okay, you can. All right. So, okay, as we saw, the difference between substring and subsequence is that substring is continuous and subsequence can be discontinuous as well. Okay. So, the code that we have written for longest common subsequence, that was like when the strings were not getting matched. Okay, thanks for the confirmation. So when the strings were not getting matched, what we were doing is we were just finding out the maximum by deleting one of the characters. Okay, but then in longest common substring, what you need to do is if the string is not getting matched, then rather than finding out the max, what you need to do is you need to replace it with 0. Okay, you don't need to find out the max. Why is it that? I will just explain it. Just a moment. Okay, so what happens in a longest common substring is, that is actually our second question of the day. So this longest common substring. So what happens here is, let us say if string Yes, next, that's correct because it needs to be continuous. So what you need to do is, let us say if we have A, B, C, D, G, H, and if let us say the second string is A, B, G, H, R. Okay. So in that case, the longest common subsequence, that is going to be 4, right? We have A, B, G, H common. Okay. But if you talk about, this is subsequence. But if you talk about substring, then as that needs to be continuous, so okay, A is getting matched, that is there, B is also getting matched, but then if you will move to C, so C is not getting matched to G, right? And it needs to be continuous. So what you are going to do is, you are again going to start the iteration from the length 0. Okay, here the maximum value that we have till now is 2 for the substring. Okay, now C is not getting matched, D is also not getting matched. Now again G and H are getting matched to these two, so again the next length that we have is 2, and we will return, we will just store the maximum value that we have of the substring. So the only difference between the only difference between subsequence and substring is, when the characters are not getting matched, then you need to replace the cell value with 0. Okay, that is the only difference that we have, and thus we have this code here, that is this one. Okay, so is this code clear for the longest common substring? Kindly let me know in the chat section if this code is clear. There is no any difference. The only difference is that rather than finding out the max here, we are replacing it with 0. Okay, because for this continuity thing. Okay, everyone, is this code clear to you all? Okay, Sarthak, so like you want me to revise this question? Or like the entire thing that we had in this session? Like basically this session was aimed towards longest common subsequence and longest common substring. Okay, and in this longest common substring, what we are doing is, it is very much similar to longest common subsequence. Okay, and the only difference is that in the longest common subsequence, as you can see, when the character was not getting matched, we were finding out the maximum by deleting one of the characters from the string. Okay, but here, if the characters are not getting matched, what you need to do is, you just need to simply replace it by 0. Okay, because the string has to be continuous. All right, so that is the difference that we have, and I hope it is clear, Sarthak. All right, guys, so if everybody just want to roadmap to master DP, but they're not interested in actual learning. Okay, so maybe these things will change with time, or like we do have people as well who are interested in actual learning, like you. So, and like all the audiences who are watching this series. Okay, thanks Sarthak, thanks Nix for the confirmation that it is clear. So all right, if we are clear on this part, then these were the 2 questions that we had for the session, and in the next session what we are going to do is, we will be taking up the questions that are based on these concepts. Okay, so that is all about today's session. Thanks everyone for joining. And if there is any feedback, any compliment, or any suggestions that you want to add, please feel free to use the chat box. And make sure you are attending tomorrow's session as well, because we will be practicing the questions that are based on LCS. Good night, Miral. All right. So thanks everyone for joining. Keep up the hard work and good night. Good night, Nix.